Cool. Today I'm presenting the paper supporting mobile sense-making through intentionally uncertain highlighting. My name is Joseph Chang, and this is a joint work with Nathan Hahn and Aniket Kittur. We are from the HCI Institute at Carnegie Mellon University. So this talk I'm going to talk about highlighting, or it is the capturing information for later use while you're reading and learning new things. So the scenarios could be like students learning a new domain, it could be scientists exploring a new field for literature, or it could be patients researching online about their medical diagnosis. And people frequently do this type of learning and exploring type of tasks on their desktop computers or mobile devices. So for example, the Evernote web clipper, which allows you to save snippets from the web page that you're reading, has over 4 million users on the Chrome app stores. For mobile users, we did a survey with 150 participants and found that people frequently conduct complex searches either partly or completely on their mobile phones. But at the same time, half of them also agreed that selecting part of the web page and saving it to be moderately to extremely difficult to do on smartphones. So let's look at how people can save information while they're reading web pages on their smartphones. So this would, if you're using the built-in browser, your options are probably the built-in copy and paste mechanism, where you do a long tap and then drag the two handles to specify which characters you want to select, and then you copy the selected text to paste it somewhere like email or other note-taking applications. And people often use this technique for selecting targeted copy and pasting. So for example, the venue of an event or the time of an event, right? But what if you're actually reading content and learning new information? So do you always know exactly where you want to highlight, so exactly where you want to select? So let's look at a scenario. So say you're doing online researching because you want to buy a new camera, and you came across this Amazon review of this Olympus camera. And you saw that it mentioned this intelligent auto mode. You're not sure what it is, but it seems important, so you want to create a highlight around it. So maybe you select the whole sentence, and it talks about other cameras that also support this IA mode. Maybe you also select the next sentence that talks about how this mode can simplify taking pictures because you don't have to deal with setting the complex menu options. What about the two previous sentences that talks about the frustrations of having or not having this mode? So I think this problem is very different than targeted copy and pasting, in that when you're highlighting, you're not exactly sure where you want to highlight. And you're actively deciding how much context you need when you're reviewing these saved information. So on one hand, if you highlight too little information, the information you save might not make sense to yourself in the future. But on the other hand, if you highlight too much, the cost of reviewing the saved information can be very, very high. So in our example, the user basically wants to create a highlight around this IA mode that's mentioned in the review, but at the same time, they want to highlight just enough context so that they can understand what this is in the future. And most of the previous selection work that focuses on how to support selecting text with high precision more efficiently doesn't really address the problem that we face when we're creating highlights, when we're reading and learning new things, because they assume that the user is certain about the exact ranges they want to create highlights on. But for many learning and data exploration tasks, we think the boundary of what text may be relevant or useful in the future can itself be uncertain to the users. And forcing them to make this hard boundary decision can be very stressful for the user early on, especially early on in the learning process. So instead of requiring the users to first figure out the exact ranges they want to highlight and then specifying those exact ranges, we propose a method where the user only needs to identify a general area of interest that they want to create and highlight, and then do a rough estimation of how much context they will need in the future. So to perform in our implementation, we use the touch-sensitive screens where if you press harder onto the screen, the system will save more context, and if you use less force, the system will save less context. So notice that not only do we intentionally not support specifying exact starting and end position, the interface also hides the exact ranges from the user using this soft fuzzy boundary. So let's look at how this works on an actual phone. So to create a highlight, you will do a force touch on the general area of interest, and you adjust the amount of force to do a rough estimation of how much context you want to save. At the same time you're doing this, you can still move your finger around to adjust the center of the highlighting. This is typically for fine-tuning if it's necessary. And once you're comfortable with your selection, you simply swipe your finger to the right, so this is a slow motion, and you'll see an indicator come up, at which point you can release your finger from the screen to create a highlight. So that's the front end, and in the back end we also made a highlight viewer where you can tap on each highlight, or tap on each highlight in the highlight list, and you expand the viewport to see more context around that highlight. So to give an overview, with the proposed technique, you initiate the highlighting mode using the force touch in the general area of interest, and you adjust the amount of force you use to do a rough estimation of how much context you need. And finally, you swipe your finger to the right, and then you create a new highlight with the selected area. So this is the front end. And in the back end, we have a highlight viewer that supports for dynamic context, where you can tap on each of the saved highlight, and the viewport will expand, and you'll see the more context surrounding the area that you created highlight. So to evaluate, we compare 3 different highlighting modes. The first one, so the 3 highlighting mode has very different level of precision for text selection. The first one we call system mode, which uses the built-in draggable handles where the user can select the exact characters they want to highlight. And the second mode we call the force hard mode, which is a variant of the proposed method, but it uses like a hard line boundary. And then finally, the force soft mode, which is the proposed method that uses this fuzzy soft boundary that hides the exact starting and end point from the user. And for each of the 3 modes, we measure the interaction time and the cognitive load of using these 3 different modes, which will allow us to answer questions like, does the uncertain fuzzy boundary make the users more stressful because they can't see exactly what they're selecting? Or maybe it makes the user less stressful because they don't really know where they want to select in the first place. So this is the front-end conditions. In the back end, we have 2 conditions, which the first one is basically our context version of the highlight viewer, which support tapping on each of the items to expand the viewport for more context. And then a baseline condition where you get a list of highlight with a fixed boundary. And we did a 2-part study with 24 participants who are all smartphone users. For the first part of the study, we focused on the interaction cost of the 3 highlighting modes, so using a targeted highlighting task. So we give them predefined targets and ask them to highlight the targets using the 3 modes, and then we measure how quickly they can complete these operations. For the second task, for the second part of the study, we give them a sense-making task where they're actually reading the content, deciding how much to highlight, and then using the highlights that they created to write a short summary afterwards. Okay, so let's look at the first study. So the first study, the participants were given articles and asked to highlight random portions of the article that's selected by the system. So these are the red portions in the articles. And then on each page there will be 4 targets. Once they highlighted the 4 targets, they'll get a new page with another 4 targets. On each page they'll get a random highlighting mode. At the same time, we also randomize the font size, the size of the targets, and the location of the targets. So this design basically tries to remove the effects of prior knowledge or the cost of the cognitive demand when they're actually reading and learning new information. So we actually asked the participants try not to read the content and just focusing on highlighting the red text. Okay, so they repeatedly do this for 20 minutes, randomized order of the 3 different modes, and then we measure how quickly they're creating highlights. So first we can look at the time it took them to create the highlights. Remember, we have the 3 modes, which have different precision on text selection. And from the results, you can see using the system mode, which has the highest precision, basically character level selection, they took the participants on average the longest, which is around 6 seconds to create 1 highlight. And the proposed force soft mode, which has a fuzzy boundary, took only about 1.7 seconds. We also asked them to finish NASA TLX surveys to measure the workload of the 3 different highlighting modes. And across all 5 factors, the system mode, which has the highest precision, also has the highest workload, and the proposed force soft condition has the lowest precision, but also has the lowest workflow. So from study 1, we learned that the force soft condition is less precise, but at the same time, it's also more efficient and less frustrating to highlight predefined targets. So what about when they're actually reading the content and deciding the size of the highlights that they want to create? So to investigate this, the second part of the study, we asked them to do a sense-making task, which is reading camera reviews, creating highlights, and writing a short summarization. So the task we gave them is this. You have a friend who's looking to buy a new camera for taking pictures of his or her young kids at birthday parties. Read 3 camera reviews and use the highlights you saved to write a short summary for your friend. So in the second part of the study, we have 19 participants. All of them also finished the first part of the study, so they're already familiar with the 3 highlighting mode. And each of the participants will read 3 camera reviews of 3 different cameras. On each review, they'll get a different highlighting mode in the front end, and after which half of them will use the no context version of the highlight viewer to write their summary, and the other half will use the context version. And before they started the camera test, we also gave them a short, like a smaller scale warm-up test. So when they're actually highlighting for the camera test, they already know what the back end looks like. So again, we measured the time it took them to create each highlight in the different conditions. On average, the patterns are pretty similar to the first study, where the system mode took them the longest and the proposed force soft mode took them the quickest. So what this says is that when they're actually highlighting, reading, and deciding the size of the highlights, the fuzzy boundary doesn't really confuse them, and in fact, they still do it. They're still able to create highlight much faster when the system hides the exact boundaries from them. You can also compare the backend condition, context, and no context. And on average, people that has a no context viewer, it took them longer to create highlight, but we didn't find any significant difference between the 2 backend conditions. We also asked them to answer the NASA TLX survey. Again, on average, the patterns are similar to study 1, where the system mode has the highest workload and the force soft mode has the lowest. But again, there's no difference. We didn't find any significant difference between the factors or the backend conditions. And then at the end of the second study, we also asked the participants, which of the 3 highlighting modes would you choose in the future if you need to read articles and learn new things on your mobile phone. So for participants in the context viewer condition, 8 of them picked the force soft mode and 2 of them picked the force hard mode. And what about for participants in the no context condition? So these are the people, after they created a highlight, the system gives them this list of highlight that has a hard boundary that they cannot adjust. So one hypothesis is that they would be bothered by it, by not having to know the exact ranges when they create the highlight, but when they review and there's suddenly this hard boundary that they can't do anything about. But in the end, we found that they still prefer the fuzzy, uncertain boundary in the front end, and 7 of them picked the force soft condition, and 2 of them picked the force hard condition. And out of the 19 participants, none of them picked the system mode. So this basically says that the participant prefers the uncertain soft boundary in the front end, regardless if they can adjust the boundary in the back end. We also asked them for qualitative feedback, which should give us some insight to about their preferences. So one participant talks about how the uncertainty enables them to use intuitions to estimate context, saying that the soft boundary took a bit getting used to, but once I got the hang of it, it made things go a lot faster. It took away the pressure of getting the exact lines right and let my intuition take over about how much needed to be highlighted. 2 other participants also directly talked about the soft and hard boundary. One saying that the soft boundary is my favorite because it's the least physical taxing, least mentally taxing. And if I'm going to highlight an article, it just has to be generally around what I want. It doesn't have to be perfect. The other participant talked about how they dislike the hard boundary, saying I hate how exact you have to be with the hard boundary. It's just a huge pain. The soft boundary is much better. And I never realized how much I hated the generic copy and paste mechanism. They also talked about limitation. So we initially thought that people who are using the no context version of the viewer will dislike the force soft boundary in the front end because they don't really see what the exact ranges are, but at the back end they're suddenly forced to use this boundary. But only one participant mentioned that he thinks the soft boundary condition, when paired with the no context viewer, is not practical because he was worried that if he was able to include everything they wanted in the highlight. So again, this is the soft condition in the front end by using the baseline condition in the back end. Another limitation is about the maximum size of the highlights. So one participant mentioned that he really liked the both force touch modes, but sometimes it feels like the maximum force doesn't give him enough size when creating highlight. So in our implementation, the maximum force is always 10 lines of text. But one participant found that that's not big enough. So to recap, in study 1, we used targeted highlighting, and we compared 3 different conditions that has different selection precision and found the proposed for soft mode to be most efficient. And in the second study, we asked them to actually read the content and create highlights. The participants, when they're learning new information, they still, the force soft condition is still most efficient, and they also preferred the proposed method. So in conclusion, we investigate the concept of intentionally uncertain input, and we show benefit that when precise input actually mismatches with users' understanding of the task or their intention. And to do that, we introduced a new interaction for highlighting, which uses a soft boundary to hide the exact ranges from the users. And in our study, the user preferred the proposed method, and we're able to highlight with more efficiency and less frustration. And with that, I'm ready for questions.
Any questions?
Hello, I'm Ray from National Taiwan University, and I have a question about in your application. I have talking about after a layout, you're forced to select a certain region, and you can just scroll to move the same region up and down in the paragraph, right? Mm-hmm. And I'm curious about in your study, is there a lot of participants using this way to adjust? Because I'm curious about they can really maintain the same force and when they're moving the finger.
Right, that's a great question. So there's previous word that talks about moving your finger on the screen while you're in the touch mode, right? But I think in most cases, the user doesn't really adjust much. So they're basically like panning their finger around to do a little bit of fine-tuning. But again, the boundary is very fuzzy, so it doesn't really matter that much how precise you are with the center of the highlighting. In addition, when you start swiping, we actually lock the size of the highlights. So at that point, when you're swiping, you don't really need to use force onto the screen.
Okay, thank you.
Thanks.
Hi, I'm Kyungmin, and similar question to the previous one, and I was wondering why you guys, so is there any specific reason for you guys to choose for the highlighting selection to be middle out types of selection, not like from bottom to top or from top to bottom types of selection? So when you press the surface, then you guys select the highlighting part from middle to up and down, right? Mm-hmm. So is there any specific reason why you guys choose the types of interaction?
So the motivation is basically the example that I give in the start. So you will have a focus that you want to create a highlight around, and then usually related information is surrounding that target. But we didn't do any tests as to if you only expanded one direction up or one direction up.
Right. So I was wondering that because people usually, like when they read the text, the natural text flow is maybe from, I don't know, top to bottom or right to left. So it is really important to consider. So I was wondering if you guys have any consideration of that.
So let's thank Yusuf for